Well, hello friends. Today we are going to work on the remote inspector thingy in Serenity. So just to remind you, this is what it looks like. Let's pick a process. How about the taskbar? So pit 15. So we connect to a program remotely and inspect its core object graph, basically. So this is the taskbar right here. We have the main widget of the taskbar window is a frame, which has a horizontal box layout, and then it has this frame here with the 3 buttons and 2 taskbar buttons on the right. And we can see if we look at the text here on the taskbar button, we can see that text property is the title of the window, but of course it's shown down here. So today what I would like to achieve is I would like to be able to set this property from the inspector by doing some kind of remote procedure call. And I think that would be a very interesting feature if we can start to modify a running program from the outside. And it's something that will open up a lot of interesting possibilities for scriptability and so on, right? And I was also thinking that it would be nice if when you select a widget here, that it would sort of highlight it in the user interface, like that you would, I don't know, you would get like a little rectangle around it or something, just to help you navigate. Because if you bring up like a more complex UI, like the system monitor, and we would connect to that, so inspector on his PID, which is 24, then you can see here that it's, there's quite a lot of stuff going on here in the interface. And it would be helpful if I could just see the thing highlighted when I'm selecting here. So maybe we'll start with that actually, because it might be a bit easier. So I haven't worked on this for a while, so we're just gonna have to refamiliarize ourselves a little bit. So currently we have, in the tree view, we have activate sound selection, and then we get this callback right here. Okay. So I think in this callback, when we bring up the properties, we're also gonna send a request to the remote application telling him, hey, please highlight this particular thing that I've selected. So this will be something like remote process dot set highlighted, set inspected object, maybe. Yeah, I think that might make sense. So inspected object, and that will be the remote object address. So we have the addresses. These are like the memory addresses of the remote objects. We have them as strings, but I think that should be fine. We can just send it over to the other guy, and he can do whatever he wants with it. So let's invent that function. Set inspected object. Something like that. And then we have to do something with this. So that would be like remote process, set inspected object, send request. So let's see, so this is how we make requests, okay? So JSON object request set type, set inspected object. This is a little different from the IPC stuff used by the Windows server, because here we are sort of serializing arbitrary object graphs, and it doesn't really fit the Windows Server style IPC. So this is how we do IPC for client server stuff normally, where we just have like a request that leads to a response. But in this case, we just serialize and deserialize JSON blobs, essentially. So we'll send a request. Of course, we should also include the address. I think we can just send it like that, no biggie. Okay, and then what happens? Do we get like a response? We seem to be getting responses here. I guess in this case, we don't actually care that much. We don't have to wait for a response, because what we care about is just that the other side does something with this. So let's go in the code that receives this, which is in the event loop. So every program that instantiates an event loop, like a libcore event loop, they automatically get this thing called the RPC server right here. And this is what enables us to connect the inspector to the program. And every connection to the inspector becomes an RPC client object. That's, by the way, that's why you can actually see the RPC client object while we're connected to the taskbar. So this is actually represents the connection that we just made from the inspector to the taskbar. It's this object right here. So handle a request. Okay, so this is where the requests come in. So we'll just say if type set inspected object. And I think, let's see, we'll have to validate the object. So auto address string is request get address to string. And then I think the best way we can validate if something is a valid object is to just iterate over all of the known objects and see if it's one of them. So maybe we can actually do it this way, now that I think about it. Yeah, let's just turn it into a number. Okay, address, and then we'll say if unit per team object is equal to address, then inspected object is object make weak pattern. So the way we'll set this up is that we will store a weak pointer here, inspected object. And so if the application deletes the inspected object while we're connected, then it will still go away. So you won't be able to interfere with like object model and ownerships and stuff like that. You'll just be observing. So we'll store it in a weak pointer, and then we should probably tell him that he's being inspected, right? So increment inspector count, something like that, because you know, you could have multiple inspectors connecting to the same process, hypothetically. It would be stupid if like two of them inspect the same thing and then one of them disconnects, and then now it's as if nobody is inspecting it. Ugh. It's hard to talk sometimes. I've been sick for a few days, so that's why I wasn't making any videos, but I feel like I have a bit of energy today, so we're gonna try this. And then when we disconnect, or when this guy dies, we'll just say that decrement inspector count. And we can even decrement inspector count. Yeah, maybe this is okay. Or no, I'll do it this way. I'll require a batch. It'll be better. We don't want just anybody calling this API. So increment inspector count batch RPC client. See, now only RPC client can call it. I'll have to forward declare that. Class RPC client. Right. And I don't have batch. Oopsie. Wait a minute. Why doesn't that work? Oh shit, right, because it's because the function is inline. Obviously. Inspector count. Okay. And let's see. Actually, maybe we should put these out of line now that I think about it, because then we can do a little bit more logic. So we'll just put these out of line. Oh, why are you here, little guy? No, not insert child before. Increment. If inspector count, then did lose all inspectors, or did stop being inspected? Did stop being inspected? Yeah, that's kind of okay. And if m inspector count is 1, did begin inspection? Did stop inspection? Okay. And we'll make this virtual so that you get a chance to override this. Did begin inspection? Did end inspection? Okay. And in the widget class, we are gonna override these guys. And this is where we'll do a little bit of updating ourselves, like visually, which is actually really simple because we're just going to invalidate and then we'll let the paint event take care of it. We got to invalidate somewhere, right? And since libcore, the core object stuff is in libcore and is not aware of GUI concepts like widgets, so we have to communicate this using a virtual. I mean, there are different ways to communicate it, but I'm just using a virtual because it's kind of a common pattern in the system to use virtuals for this type of thing. So did begin inspection. We're just going to update. This will just cause the widget to get invalidated and repaint it. By the way, this is how we learn the properties of a widget. When the RPC client gets a remote call asking for all the properties of a widget, then we call this save to virtual, which then populates a JSON object with all of the relevant properties at each step of the class hierarchy. And you can see here that this widget gets the call and he adds his particular set of properties that he thinks are interesting, and then he passes the call further up the inheritance chain to core object. And then core object will add a couple of things as well. I think name, address, class name, stuff like that, right? Anyway, so Now we got to do something when we paint. So how are we going to do this? Paint, handle paint event. So handle paint event is the function in GUI widget that actually gets control immediately when the literal paint event is passed to us. And then it does a little bit of setup, filling the widget with background color if necessary, and then it calls the virtual paint event, which allows the subclasses to implement their own custom painting. And then it also recurses through children and makes sure that they get to paint as well. But I think what we're going to do now is we're going to say at the very end of paint event handling, we're going to say like if m inspector count. Oh, we can't. Okay. Being inspected, maybe. I feel like that's what I call it in the kernel when a process is being inspected. Yes. So I think we can call it that here too. It's kind of cute. If it is being inspected, we'll just, well, why don't we just make a rectangle? So let's see, painter, and painter draw rect, my rect, color, magenta. It's always magenta when I'm doing stuff like this. I don't know why. And then let's add that little helper guy that tells us if we're being inspected. Is being inspected. All right. So, do we have everything in place now? I feel like maybe we have everything in place. We'll see. So the let's follow the logic while it compiles. So when we activate something in the tree view in inspector, we'll now tell the remote process object set inspected object to the remote object address, and this will create a JSON object request with this type string and with the address we were passed, and then send it to the other side over a socket nonetheless. Maybe we could combine these into a single write, actually. Could use write v for that. We don't have okay, I'm getting sidetracked. RPC client will receive this on the other side, so we'll be down here. So this is RPC client handle request. Set inspected object, we get the address, convert it to a uint putter t, and then search through all of the known core objects and see if we find somebody with this exact address. If so, we will set that to be the currently inspected object and increment its inspector count. And I feel like we're forgetting one thing here. Oh, and apparently we forgot a few more things, but if we already had an inspected object when we're switching it out, then we should let him know that he's no longer being inspected. Let's see. If it's no longer being inspected, yeah, that's okay. I was trying to get fancy here, but I think we're not going to get fancy. And this is supposed to be did end inspection. And this guy has an incomplete type. Well, implicit instantiation of the badge template. That's my bad. That's my badge. Oof. Basically, everyone in my office was sick lately, and I was like the last one to get it. So It's been a very uneventful week here. No videos, no interesting hacking, no commute talks. It would be really nice to just get back to business. I guess this is a step in that direction, right? All right. Let's help it along a little bit. Wait, why is the kernel finished? Oh. So much to rebuild when you change libcore. But this will be good. This will be good. And we should follow that logic some more. So where were we? RPC client. We were getting the call to set inspected object. Now we decrement previous inspected object if possible, and then we increment the new one. And if this is the first increment, then we did begin inspection, and if it's the last decrement, then we did end inspection. It's straightforward. And then these guys will trip up an update, and then handle paint event will put a nice magenta rectangle around anything that's currently being inspected. And holy moly, why is it taking so long? I feel like this is unusually long today, but there we go. All right, so PID 15, still taskbar. It's nice with the predictable PIDs for this kind of stuff. This is definitely not doing anything interesting, so on some level we have definitely failed here. We're gonna have to find out how. I guess we can start with printing out the request that we send and also the request that we receive. So set inspected object received. Maybe we should log the full requests that we get actually. RPC client, RPC server received. Request to string. Boom. And let's see what core and applications taskbar. Well, that's not a command, is it? And I guess we can also rebuild the inspector. All right. Okay, so we're being told set inspected object. I suspect that we are not converting this properly because this string is like 0x, and I think the JSON string stuff is not going to convert that correctly if we're sending it as a string. We should send it as a number. Set inspected object. To int. Oh, we don't have the a way to convert it from hex, I think. So who's calling this again? Just and the address, and I think we can just yank out the address from the JSON object. That might be easier. And we don't have the formatted version. So we'll just pass it along like that. To number u in t. Okay, that's weird, but maybe it's okay. Set inspected object, u in t. Oh. Okay, they're always 0. That's not better. Dang it. All right. So what's this actually called then? Wow, this is so huge here. Well, we have address. Oh, and the addresses are like 0x, this and that. Why is it like that? Core object. Why do we get them as strings? I guess we're sending them as strings? Yeah, look at this. We're just sending it as a string. That's a bit goofy. We could also send it as a number. So why don't we do that instead? T of this. Oh, that looks so strange. Let's do it this way. Cstylecast, everybody. Parent. I guess it's probably like this because I was trying to stay 32 versus 64-bit safe, but this was before I started applying u input t throughout. Now the code is a lot better about 32 versus 64-bit, and it's not perfect, but I've actually gone through quite a lot of stuff just to prepare for the eventual 64-bit port. Because this type of stuff is like, it's easy to fix, but it's nice to fix it incrementally instead of like once we do the port, and then we would have a monumental userland fix-up task as well. Anyway, well, that did not work. Can we boot again? Yes, it did work. That's a little flaky, not the best. So now we have the address as a number at last. All right. So look at that. You can see some magenta. There's a magenta rectangle. That's very cool. And then you can look at what you are selecting like this. I think that's really, really nice. And I think that's going to be really handy for using this as a tool. So it kind of makes me want to connect to something bigger. System monitor. Aha. Inspect 21. All right, so let's look in this program. Tab widget. See, it's the vertical splitter right here. Tab widget, of course, has many children. This is just a currently open tab. And if we open him, we see. So this is actually really, really cool because one thing that I end up doing quite a bit, whenever I bring up like some program that I didn't work on for a while, it always takes me some time just to sort of read through the code and figure out, okay, so how is this layout set up, right? Because a lot of this, or everything, is just using programmatic layout. Now we're actually able to visually see how things are laid out. Obviously, it's not perfect, but I do think it goes a long way, just having something like this. And here's another interesting layout. So we have the switch. It's this widget right here. Oh, but it doesn't update. Oh, that's a little annoying. So it's lately instantiated, and then the object graph does not actually update. So we reconnect. So we get the full object graph, and then we can see lazy widget has been instantiated. We can inspect it. See? Group boxes, stats widget, labels. Man, this is so cool. I could just do this all day, but that's not terribly interesting. Or it is for me, but we should get on with programming. So let's see. Let's commit this. So what do we have here? Git add. Libraries live core. Core. Allow a RPC client to specify the currently inspected object. A set inspected object call that tells us which core object a remote RPC client remote RPC remote client is currently looking at. This objects get notified when they gain their first inspector and when they lose their last one. I guess we can actually, let's commit everything together here, because otherwise it will be weird. GUI plus inspector highlight the currently inspected widget remote. This patch adds a magenta rectangle around the currently inspected widget. This allows you to visually somewhat to browse apps widget tree somewhat visually using the inspector. Very cool. Okay, so what if we want to set some properties? Because that's what I was talking about in the beginning. This was supposed to be just the first thing, right? So let's imagine that we want to change the text of one of those taskbar buttons. So taskbar button is a derived class that inherits from GUI button, which inherits from GUI abstract button. An abstract button is where the text is actually stored. So that's where we serialize the text in the save to here. So I'm thinking we would have something like set property, and here you would sort of be able to call this with any of these things and a value, and then we'll try to set that property to the best of our abilities, I guess. So something like this, and maybe we should have a bool actually. We can return if we succeeded or not. And then we'll just do something like this. Then mText is value to string, return true. And this is not super beautiful, but I think maybe we can start with this type of thing, and if this grows out of hand, then we can figure out what to do later. To bool. Wait, what's wrong with that? To bool. Oh, I'm assigning it to text. And checkable is value to value to bool. And I guess if you change the text, then we should probably update. So in fact, maybe we should call this set text. Yeah, we'll use that, because that one will take care of updating visually if needed. So like that, set checked, value to bool. Yeah, we should go through the setters, otherwise this will get really weird. Set exclusive, value to bool. All right, and if we can't handle it, then we will call our base class, which is GUI widget. So return widget set property name value. All right, and let's add this virtual. So we can make it look like that actually, and this will be on core object. So save to. Save to is kind of a strange name now that I think about it. I don't know, what's that? What would be a better name? Maybe like save all properties, serialize, or I don't know. We don't have to rename it now. But just something I'm thinking about now. Okay, so now we have set property. What are we going to do with that? I guess we can re-implement it on widget as well. So widget CPP. What's widget going to do? I guess I'll just look at the name and decide what to do based on that. So if you try to set the relative rect, then set relative rect. That's a bit weird. We're going to get rect as a string. I think we'll say fix me. We'll assert not reached here for now, because I don't have a way to turn a string into a rect, and I don't want to go into figuring out how to do that right now. And just in case we can't handle it, call base class. All right. If name is fill ref background color. Set fill with background color value to bool. Return a true. And tooltip. Oopsie. To string. There's so many of these things. I think we'll just leave it like this for now. We'll set a couple of them, but not all of them. Maybe enabled. Oh, focused is kind of interesting. Okay, these are all kind of interesting. I was going to add some more. Set visible. Yeah, we need to add more of those, but not all at once. Okay, so now that we have, again, made it necessary to do a big rebuild, let's go and add some stuff to the RPC client. So we're going to get a request of some type. I guess if type is set property, say. And then we'll do the same thing here to figure out. Actually, we should break after we find the object. Don't have to keep iterating. We can even return. Okay. Return break. And then I guess we'll just call it set property name, which will be the request get name to string request get value. All right. Simple as that. Do we need to generate a response for this? I guess we can say like succeeded or failed. So we'll make a response. Oops, what the heck did I just do? Full success. Response set type. Set property. Response. Something like that. I don't know. This should probably be synchronous, but right now it's not. But it's still nice. Nice protocol, I think. Okay, so in remote process, is this thing still working? No, it's not. Core object, we forgot to actually implement it here. Set property. String view name JSON value. It's supposed to be a bool. No, not save to. What am I doing? All right, so if name is name, set name value to string. All right, value return true. Right, and then the other ones, we can't really change the class name or the address or the parent, so let's say we can't change those. Oops, that's not what I meant to do. Right, so in the remote process, let's add a new function. This would be like, do we have a remote object? We do have a remote object thing. And where are these stored? In the remote process. Okay, so in these guys, we'll do something like void set property string view name const JSON value. And how do we get to the other side? I don't know how to get to the other side. Okay, maybe this is the wrong place to do this. It feels right, but it's not going to work. So we'll do it in remote process. Set property, human property, object, footer. Name const JSON value. All right. Process set property, and we will create a request. Now a set property request, and value is going to be value, and send request. Oh, right, like this. Name. Wait, why can't I? Why does this not work? Can't convert a string view to a JSON value. What about JSON value like this? Does that work? It does work. Explicit string. Oh, there's no string view helper. Well, all right. Well, whatever. We still don't have an interface for it, so we'll need a UI. So let's make the table on the right-hand side editable. I have not used this forever. And I only ever used it once, but we'll see if we can figure it out. Properties, table view, set editable, true. And then the way that it works is you have to create an editing delegate, which you set on your view. Right, so I've only ever used it in one place. And the editing delegate is one of these guys, a GUI model editing delegate, which knows how to create a widget. Okay, I'm just going to copy this guy right here. Maybe you don't need to, but well, let's see what happens if we just run this actually. I don't remember what happens if you don't provide an editing delegate, but you just make it editable anyway. So what happens if I just try to edit? Not much. All right, so table, edit. Who cares about this? The table view. Double click event. All right, so if it's editable, then begin editing. Then we ask the model if it's editable. Oh shit, our model is not editable. Remote object property model, we have to say virtual bool is editable. Return a true. We can actually customize this per property or per index in the model, but we're just going to lie and say that everything is editable. We could imagine wanting to do this so that like the class name would not be editable, but other stuff would be, stuff like that. But right now everything should be editable, so let's just see, and then we die because we don't have an aid create editing delegate hook installed. That's fine. So in the inspector main, we'll just install one. Tree view aid create editing delegate should return an home footer to model editing delegate, right? So just do something like this. Return make GUI model editing delegate. Is this possible to just make one like that? I think maybe we can, yeah. I mean, if it's allowing us to do that, then it's not that simple, is it? I am instantiating an incomplete type. That's my bad. It's abstract, is it? Dang it. Oh, I see, I was not paying attention. Then why do you have a public constructor? That's so useless. Put that down here. So who inherits from this guy? String model editing delegate. So here's a convenience class that we can use. Let's use it. String model editing delegate. Okay, and we cannot do this because we get an argument of some type, an index, of course. I guess what we should do with the index is pre-populate the editor with whatever we're reading from the model. I don't know, we'll see. All right, so wait, that did not work. But I installed this thing. I'm setting it on the tree view. Damn it. Okay, that makes sense. It's supposed to be on the properties table view. I don't want to edit the tree view. Plop, plop. Look at that. True. And then we die if we try to change it, because what happens? What the heck happened here? Event dispatch fails. We are asserting that, what is this exactly? Core objects dispatch event. That either there's no stay within, or that we're supposed to stay within this, or that stay within is an ancestor of this. All right, so we're gonna have to learn a little bit more about this. So let's see. I'll call this the boo-boo condition. This should be true. If not boo-boo, then debug. So we're gonna die now anyway, so stay within. I guess we should log what this is. Stay within. We can log the event type. I don't know, just to see what we can find out. What is going on here? Okay, and we are here. So the text box, we have an event for it, event 1013. So let's figure out what that is first of all. So GUI event, that would be Keyup. So I guess I'm pressing return, and on the Keyup event, something goes a goof. And I wonder why. We'll have to find out. Text editor, Keyup. Where's the Keyup? Text editor does not even care about Keyup event. Widget does not care. Actually, Paintbrush and Piano are the only apps who care about Keyup. Keyup just does not get much love. Okay. So that means that we are in the event loop, and then we call dispatch event, which happens here. And that brings us here, and stay within is null, right? No, it's this. Okay, so wait, what does that mean in practice? That means that, let's see, dispatch event. Dispatch event. Oh, this is the core object dispatch event, the first one. And then we end up calling, it gets passed up to the window. And then the window tries to pass it on further. That's a bit weird. I feel like I've looked at this issue before, but I don't recall. So event bubbling is, it's important to get it right, and I can tell that it's not quite right at the moment. Basically, the idea is that if a widget does not handle an event that it gets, then you want it to bubble up to the parent widget so that the parent gets a chance to handle the event. And that's how you're able to do stuff like having a bunch of small widgets and you can let them have focus, but if you press something that individual widget is not interested in, then the parent widget gets a chance to handle that key press, for example, or whatever other event. But here we are in window event, and we are getting a key up, and we are calling main widget dispatch event this. So let's see. So here the event ends up in the window. That makes sense because the window is the first recipient of Keyup. Because all events come from Windows Server and they go to the window, and then the window distributes the event to like the focused widget or whatever widget, the hovered widget, and so on. So this here, Keyup, tries to send it to the focused widget. It's called dispatch event. And then we are here, and presumably stay within is the window. But why does that fail then? Is it that it's not that the window is not an ancestor of the thing, perhaps? Could it be? Let's see how this is implemented. String model editing delegate. So we create a text box, and on return pressed commit. And commit does the model editing delegate thing. And call stop editing. Wait. Okay, I have to follow how this works. Editing delegate. We create an editing delegate, and then we ask the editing delegate to create a widget. Where does it create the widget? Oh, it creates the widget here. And the widget is like that, okay. And then the abstract view takes the editing widget and turns it into a child. That's fine. And then when we stop editing, then we remove the child. So that basically what happens is when you begin editing something inside of an abstract view, then we instantiate a text box, and then we put that text box inside of the view, let you edit it, and then when you press enter or return, we call stop editing, and we remove the the text box from the abstract view, so it's no longer a child of it. And then when we try to send an event to it, then it gets a little screwy. I think maybe it's because it was focused and it's no longer focused, and then we're trying to send an event to the currently focused widget, which is, we still have a pointer to it, but it's not a child of this window anymore. I think that's probably what the issue is. So I guess we can verify that by just dumping it out. Core objects dispatch. Actually, we don't have we can't see focus here, so that's not going to help us. But let's just fix it instead. So I guess the issue is that we need to clear the focused widget in case that widget is removed from the window. Then he can't be the focused widget of that window anymore. So how the heck does that work? guess in widget set focused widget. Right, so we kind of want this logic, except somewhere where a widget is removed from its parent, from its child, removed from parent. So we'll get a child removed event. And what happens with that? Child event. And this will go, let's see, widget will get this. Okay, so widget gets child removed. And I think we could do something like if event child, or how do we do this? If event child and event child is, what is that? Oh, it's not a, I want this logic right here. If we have a child and it's a widget, and is and core to widget event child. We want to know if it is focused. Then, because then we are removing the currently focused widget. So we'll say if window. I mean, we do have a window, because otherwise there's no focus if there's no window. So focused widget, no footer. Okay, this is a little bit awkward. It's like focus is a window level concept, and now we're sort of making it the responsibility of the immediate parent of a widget to clear focus in the window. But maybe it's not the worst thing in the world. And it still did not work. All right, damn it. Did we even get here, I wonder? Let's see, child removed. Child removed. Clearing focused widget. Else. I just want to see if this happens. Not clearing focused widget. Alright, we're getting real fancy here now. Just tell me what's going on. Alright. I don't see anything. I guess I did not get the child event. Okay, so why did we not get a child event? Dispatch event. Let's go to GUI window. Okay, here, when we're choosing to dispatch to the focused widget, we'll say like, if is not ancestor of focused widget, I am not an ancestor of the focused widget. Assert not reached. I just want to see it so that I know that that's the bug, because maybe I'm wrong. Okay, I was not right about this. Damn it. All right, so we're on the wrong track. good that we find out. Or wait a second, I'm not rebuilding the right stuff. Damn it. Okay. Well, that's not gonna help. We gotta rebuild the right stuff. Okay, well, this explains why we were not seeing any of the messages. The build system. All right, now let me add them. Oh, not clearing focus widget. So we get child removed, but we're not clearing the focus widget, and then we say, I'm not an ancestor of the focused widget. So we have the right idea of what the bug is, but we're not clearing it from the focus for some reason. Not cola. The clay is silent. All right. Child removed. Let's see. Child. Can we just do that to get a footer? Yeah, okay. Child. Debug. I'm not clearing. Dang it. And I guess we can just do something like this. I just want to know what it is, all right? Just let me see it. What is focused even check? Check if the window is active. If the window is not active, well, that's a bit strange. We shouldn't care about that. So is focused is probably not the right way to approach this. Some text box. Okay, so we know that it's a widget. Let's say that if window focused widget is equal to event child. Why don't we do it this way instead? See, that's downright readable. It reads way better. If there's a child, because the child pointer can be null if the child has been completely deleted already, in which case there's nothing we can do, but that's fine because the focus widget is a weak pointer anyway. So if it's null, right? We just want to clear it out in case the widget still survives, and the window still thinks it's focused even though it's not. Okay, now we are getting somewhere. All right, so that did the trick. Good. Let's see what we can do with that. And we don't need all of these things. There we go. Note. Let's say fix me here because I don't really love this. Fix me. It's a bit awkward that the immediate parent of a removed child is responsible for clearing the Windows focused image. However, if we don't take care of this, the window may try to dispatch an event, dispatch events to a widget not within its own tree. Yeah, it's pretty good. I mean, it's okay. I don't want to call it great, but think that we did an okay job here. Yes, no, quit, git commit, look GUI. Clear the Windows focused widget. Don't. Widget if focused widget when it's unparented. Previously, the focused widget would only get cleared on replacement or on destruction via weak putter. Being a weak putter at all. This could lead to window dispatching events to a focused widget after it had been removed from the Windows widget tree. Okay, and I guess we can lose that goofy thing. And I had some other thing, just some little thing here. Yeah, this one. Auto editing delegate with GUI. Make the auto editing delegate constructor. Okay. And then it's just a bunch of set property. All right, so now we're getting to some more interesting stuff. Also, I realized that you can edit the property names right now, so we can at least, disallow that because it's a bit weird. So we'll just go in the remote object property model. And for is editable, we'll say return index column equal to column value. So only the value column is editable. Okay. Let's see if this actually generates. I guess this is not going to generate anything because we still need to actually react to the data changing. So how do we do that? Model editing delegate. We do commit. Okay, and here what happens is we call model set data. All right. Model set data. Oh, interesting. And then we can do whatever we want with that. So we got to implement that. I totally forgot how this works because I haven't used it in forever. So in our remote object property model, we'll just override set data. And we're going to do some cool stuff in this. So here, now we need access to the process. How do we get that? Remote process. I need access. Give me access to you. Duh. Returns the. All right. nice and simple. And a little bit ugly, but who cares? Then here we could just get the remote process, the set property. Then we need the address and the name and the value, right? Okay, so how do we get these now? How do we get these now? We'll have to ask the we have the properties here. Oh shit, yeah, we can find them like this. So the properties are name and value here. And we have the remote object here. Okay, all right. So this will be our thing. So now we have the property name. And then we don't want to use the old value, but we're going to use the new value. We can even call it the new value. Then the address is going to be the unit property address is mObject dot get JSON get address to number unit property. Maybe we should actually update something here as well. It's property name to string. All right. Can't convert you to a JSON value. I'm just gonna make it a string for now, whatever. So it's not gonna be perfect, and I won't be able to edit all the data types, but it will be a start. All right, so let's just say that we'll update the property value to reflect the change that we made, whatever we do. So we'll say like property dot value is new value to string. So this may not reflect what actually happens on the other side, but it will make the UI look as if we changed the property, no matter what. Let's see if it works. So I am feeling spicy. Let's try to change the terminal title down there. Put an X up front. And it worked. Look at that. That is just really cool. That is cool. Okay, so now we are actually changing the state of the taskbar program. Change state while it's running from the outside. I really like this. All right, so what happens if we try to set something that we can't set? Taskbar button is foo. See, it looks here like you changed it, but you didn't change it. And that's a bit stupid, but like if you reconnect, then it won't be reflected, of course. So let's connect to something else, like why don't we connect to help? Open something here, pledge page, and connect. Okay, so now we are connected to help. And look at this, we can see the different widgets. Got these buttons right here. This guy, let's change his tooltip. So tooltip right now is go back. We'll change it to go back yo. And that killed the inspector, but it does say go back yo. So that's awesome. Now, why did it kill the inspector though? Assertion failed window. So we're getting a leave event in a text editor after it doesn't have a window anymore. So I think we need to handle that more gracefully. Leave event. So you can apparently get a leave event when you don't have a window. Why does that happen? Oh shit, wait. This this is valid assertion because this should not be happening. So I think maybe we have another one of those focused widget issues. So we also have like a hovered widget. And I think, yeah, that it was probably hovered. And then when we removed it, then we got event. So let's try that again. Just editing a property. See, now we can't change the name, but well, I'm hovering this text box. So and I move it. Yeah. Okay, that's the thing. So hovered widget needs to also be reset. And here we also have the same type of setup, so we can actually change that as well. Windows focused widget. Maybe we should have some kind of a more general thing here. We'll say like window did remove widget, something like that. Core to widget. That's so awkward that we have to say core to. Can we just do it this way? Move on. Oh, that one's missing. I'm an idiot. Do we have GUI too? No, it's all core too. All right, whatever. Windows focus. Yeah, you know, this actually becomes a lot less awkward, so we can even get rid of the fix me if we do it this way. Because now we're just letting the widget know that we're letting the window know that some widget within its widget tree was removed. So saying did remove widget, and we'll only let widget call this. I guess like that, yeah. And the badge goes here, all right. If m focused widget is widget, m focused widget is null footer. If m hovered widget is widget, m hovered widget is null footer. If m widget. Do we have more of these things? Cursor tracking widget, automatic cursor tracking widget. So yeah, we should probably nuke all of these things. It's a little bit, this is a little bit awkward. I wish it would be automatic somehow, but this is as automatic as we're going to get right now. Okay, I think that's still really good. So yeah, now widget will always notify window if a child widget is removed, and then window knows. Window h did remove it. Okay, means that we can edit this guy here, file manager. Let's edit his tooltip to say a file manager 2. And no crash, file manager 2. Very cool. Web GUI widget, CPP. Okay. Yes, no, quit. And let's squash that into a previous one. Fix the squash into the focused widget commit. And what do we have left? Just the set property stuff. And then calling that from the inspector. All right, so loop core. Core. Add a way to set an individual property, individual core object property remotely. Very cool. Wait, hold on. Wait. GUI. Implement set property on jet and abstract button. This makes it possible for a remote client, remote process, remote client, for an RPC client to modify some state, modify properties. Interesting. Properties. Inspector. Make properties editable and allow changing remote objects. Allow editing. Allow changing remote properties. Tweaking? This is too long. Make properties editable. Allowing me to change. Make properties editable. Allowing. Okay. There we go. This patch makes it possible to live edit remote object properties by simply double-clicking on them in the property table view. This is pretty neat. Double face. Right, the squash. Clear some of Windows widget pointers immediately, eagerly, when on child, on parenting. We put our eagerly. Say forget. The same issue existed for other widget, etc. Dispatch. So dispatch removes or makes sure that we eagerly clear the various widget pointers in window immediately when they are removed from the Windows widget tree. Okay, so that's pretty good. Let's see, I wonder, I was just thinking about Minesweeper, because like, I wanted to connect to Minesweeper for some reason. I can't. Oh, right, because I didn't rebuild Minesweeper. So let's make sure we do that. So I was thinking, what if you could use this to cheat at Minesweeper? Wouldn't that be nice? I still can't connect to it? Why is that? Got JSON response, remote process update. Okay, I don't know what's wrong with that, so we gotta look a bit closer here maybe. Let's make sure that we do a full build first, but remote process update. Oh, is it that we are getting some kind of response that we don't know what to do with? We're here. Length. The waiting for the rebuilding. Okay. We are almost there. There are a bunch of, I should mention this somewhere, that right now there are a bunch of people on the Serenity OS subreddit who are actually trying to assemble a new computer for me from donated parts. And it's very, very nice of them. And I certainly would definitely be very happy about a stronger machine. So there's this thread here started by Charlie Horse 55. And he's found some parts already, still looking for some other stuff. In case anyone wants to look at that. Feel a little bit awkward about it, but I definitely want to promote it in case it leads to a stronger machine. Anyway, so let's see what the heck is up with Minesweeper. PSE. Come on, Minesweeper. Why can't I connect? Okay, this is not right. So this is the JSON response. And why don't we like that? Remote process 155. So we're here. Okay, so let's dump out what we got then. Got length. Got datum. I don't know, something like that. I'm thinking, like, why would it fail? Like, what would be so different about Minesweeper? But I guess we'll find out if we manage to connect to it. Okay, there we go. It actually dies here. maybe it's, oh shit, it's like, it's so full that it probably fills up some buffer and we don't know what to do because we expect everything in one packet. Could that be it? What was the length that we got? What is the, oh man, this is so long. 72. Yeah, so I know that the internal buffer used by local socket is 64K. If we look at the local socket, it's a double buffer and he is 64K. So this does not fit in a single packet. That's a bit troublesome. So I guess we are going to need to handle that situation. But what a great opportunity to fix one more bug. Let's see. Maybe we can do a read all. Does that work? Read all. What will that do? So fstat is kind of meaningless on a socket. I wonder if read all will just work. I'm not sure. It should work, but what is it? Well, that's the wrong program. Yeah, it's 20. All right, so we can't connect because it's too long. All right. So we can't use read all. But what if we just use a loop then? So byte buffer data. Is byte buffer append? Yeah, we can always append to a byte buffer. So for, let's say remaining bytes, I guess, is length. Okay, and then while remaining bytes, packet, packets. We should not read all, but rather read at most remaining bytes. Okay. Is this a thing? No, it's not. Okay. Packet data and packet size, remaining bytes minus packet size. Okay, and then we have data. Read all should probably be fixed so that it does what you expect it to do. I just don't want to start messing with that right now because I'm going to break something else. So that did not work. Why does that not work? I'm trying to grow data.append. And maybe the data size is 0. Okay, so if packet size is 0, that's a bit strange, but all right. Then we have the wrong length. Oh, this is so frustrating. Or not super frustrating, but I guess this socket is probably non-blocking. And we kind of want it to be blocking. Can we just make it blocking? Set blocking. Okay, so who uses that? Oh, we're going to try to use that. Because otherwise it will just return right away because we're waiting for the other side to send more data. So msocket is instantiated where exactly? Msocket here. Okay. And we'll do msocket set blocking true. Okay, well, we are going on for quite a while today, it feels like, but a lot of interesting little things happening, so. Aha. Okay, that did the trick. Now let's see. So here's the reason that data is so freaking huge. It's because of all of these guys. See, each square in the Minesweeper game is a widget. And underneath each button, so there's a button on top, and then if you click it, you reveal the label underneath. I was thinking if you could cheat at this somehow, but you would need to look at the... No, there's currently no way to cheat, but we could expose the state allowing you to cheat if you wanted to. If you wanted to be a dirty cheater, which I guess would be a little bit fun. But if you add cheating, then it takes away the fun of the game also. So let's make a cheat, but let's not commit it. So let's see. First, I gotta get rid of all that noise. So that's all in remote process. Got JSON response. Blah, blah, blah. Wait. Maybe that's okay. Yeah, that's okay. Inspector handle incoming RPC responses that are handle multi-part RPC responses, multi-packet. This makes it possible to connect to Minesweeper. Which has a huge, rather huge tree. Okay. So, Minesweeper. What am I looking for? I guess I want to know if a given button has, a mine under it, right? So how would I know that? We need to look at, well, currently I don't know that actually, so, but if I make it so that square buttons know they're square, we'll do it this way. Square button, square. And then we'll override save to JSON object JSON. GUI button save to JSON. Square dot. Oh, I don't even know what we have in that state. Forget. The square has mine. Okay, so has mine. Yep. And then we just need JSON object. We're getting kind of silly now, but this would just be a nice way to wrap it up, I think. Because this brings us back to the first feature we were doing, because I'm not going to edit whether it has a mine or not, but I'm just going to see it visually. Just for funsies. So come here, you. Okay, so this guy right there. Has mine true. See? So I don't want to click on that guy. This guy does not have a mine. Click it. See? You could totally play like this. This guy right here does not have a mine. Oof. Amazing. Let's click one that has a mine. And who has a mine? Oh, we should alphabetize those things, by the way. But I don't want to do that right now. Okay, can I just find a mine somewhere? I guess the very last one is gonna, almost last one is gonna have a mine. Where is it? This one has mine. False. See, that doesn't seem true though. Why do you say that you don't have a mine, bro? Because you did. So that did not work quite right. Wonder why. Oh shit! I think that we are. I think we're kind of rejigging the game because there's this mechanism where the first click should never hit a mine, and it should never hit a number either. So it should always be like a revealing click, if you know what I mean. So now that the field is actually, now the field is ready, but before, because what happens if you click on a mine with your very first click will secretly re-randomize the game so that you're guaranteed to never hit something on your first click, because otherwise it would be so sad if you did that, you know? Also, these pointers here look kind of stupid. Should make them hexadecimal. So, has mine false? Of course it does not. But this one should be true. Yes, it's true. So let's click it and we die. Alright. Cool. I'm gonna fix that pointer name thing. Remote object address. String address. Wait, where are we even storing that? Who creates these? Get address to string. Maybe we'll do it this way. This will be a nice cleanup anyway, because I don't want to have it as string. To number, you interpreter T. Objects by address. Oh, this one is indexed by string. See, we can make this better here. Very nice. Remote object graph model. See, now we can do it this way instead. Yeah. And I think this means that we can get rid of a couple of silly conversions that we were doing. Because now we have the address right there in object address. And when we do set inspected object, we can just say address like that. All right. Okay, I think we're going to wrap it up now. Just a last check here. We got hexadecimal things again, and let's change the inspector title in the taskbar to hello. Okay, very cool. All right, I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. I feel like we got a lot of interesting stuff done today, and it's really nice to come back to work more on the inspector, because it's really like, it's almost like the shell of an interesting underlying feature, right? Like this remote programmability of applications on the system. Like the better we make this mechanism, the more scriptable the user interface becomes and everything. I think there's a lot of potential there. But anyway, this will be it for today. So I hope you saw something interesting, and I will see you next time.